Generative Pre-trained Transformer 2, GPT-2, is a language model which was released by OpenAI in February 2019. It was trained on 40 gigabytes of high-quality, human-curated text to predict the next word that should occur after an arbitrary prompt. Architecturally, it is a deep neural network that uses a self-attention mechanism to selectively favor the parts of the input text which it has learned are more important. The checkpoints for this model, which OpenAI released, were very prose-inclined because its training set was prose-dominant. It may be easier for machines to create poetry that can pass a human's test for legitimacy, because grammatical derangement and perplexing vocabulary are more common in poetry than in other popular kinds of writing. Therefore, we retrained the publicly released checkpoints to specialize in poetry using resources from the open source community. Specifically, training code from a GitHub user called NShepherd, a dataset based on Project Gutenberg's corpus, and another dataset based on Poetry Foundation's corpus. Training with the above code was straightforward using the partial release of February 2019 from OpenAI, a version of GPT-2 with 117 million parameters. Better results are expected from the larger models, such as the 345 billion parameter version, published in May 2019, because it has greater layer depth, more attention heads, and more parameters in which information can be maintained. For local training, we had access to 12 gigabytes of VRAM, which is not big enough to fit a single batch of the 345 million parameter version into memory during training in the standard manner. So we used gradient checkpointing to lower the space, memory, requirement by 90% in exchange for increasing the time, computation requirement by 20%. The method involves discarding intermediate model states and recomputing them as appropriate. The largest version of GPT-2, published in November 2019, has 1.5 billion parameters. Its space requirement made it unfeasible to train with our local hardware. Following the path of Gwern, we applied to Google's Tensor Processing Unit Research Cloud program so that we could train feasibly with remote application-specific integrated circuits. We were successfully invited onto the program in March 2023, but after trying the two zones in which access had been granted to free Tensor Processing Unit devices, US Central 1F and Europe West 4A, many times, we always received the "there is no more capacity in the zone" error. Therefore, Gwern gave us their blessing to use the outputs from their experiments with Sean Presser, which were conducted until December 2019. Subjectively, we deemed the results at a cross-entropy loss of 1.3 to be the most appealing. Since the model generates poems that are usually at least 100 lines long, we searched for segments that satisfied some line length and word length constraints as a kind of standardization. This eliminates most demonstrations of sensible starts and ends of poems, and the ability to maintain subject matter over more than the line length constraint. However, such demonstrations seemed sufficiently rare to not be worth keeping at the expense of the ease of consumption which the standardization facilitates. We sought to have part of the poems in this collection take 30 seconds to speak, and the other part take 1 minute to speak. Assuming an average speaking rate of 120 words per minute, we implemented the standardization with the following procedure. The first segment of 16 lines containing between 110 and 130 words was extracted from each sample until 351 candidates were obtained. From each remaining sample, the first segment of 8 lines containing between 50 and 70 words was extracted. This resulted in 342 candidates of 8 lines. Stable Diffusion, SD, is a text-to-image model which was released by Stability AI in August 2022. It was trained on 5 billion captioned images collected by a web crawler. Architecturally, it utilizes a sequence of residual neural network-based autoencoders which are trained to successively remove noise from images. This reverse diffusion procedure is augmented by a cross-attention mechanism to enable the feature of being conditional on text prompts. A team from Runway ML retrained the Stable Diffusion V1 model from the Computer Vision and Learning Research Group at Ludwig Maximilian University of Munich. They improved classifier-free guidance, CFG, sampling, and published their resulting checkpoints. We use checkpoint V1-5, which has endured 431,000 more steps at different resolutions, and then 595,000 more steps at 512 by 512 pixels on images from the LAION datasets. We used the popular Stable Diffusion WebUI repository to interact with SD. At least 18 candidate images were generated using the entire text of each poem as a prompt. 6 of those were manually selected to be published with each poem, and one of those 6 was manually selected to constitute the contact sheet style cover of this book. The manual selection process greatly penalized images which included pseudo-text artifacts. 20 Euler A sampling steps and a CFG scale of 7 were used to create 512 by 512 pixel images. With this configuration, we could run batch sizes of 6, consistently using 10 gigabytes of VRAM.